All right, so today we're going to take the notes on the different plate boundaries, and I have some examples to show. You will need a pencil, a blue marker colored pencil, and a red colored pencil or marker. So a divergent boundary, diverge means that the two plates are moving apart. And I like to draw that with just two little arrows. They are diverging away, moving away from each other. This can happen between two different crust types. This can happen between two oceanic plates or two continental plates. So one is an O, one is an O, and the other interaction is when there's two continental plates. One is a C, one is a C. All right, so I'm going to kind of zoom in here on the drawing of the oceanic and oceanic. We start by drawing our plates. So this is a crust, and the crust type is oceanic. So I'm going to write that on there. And they're moving away, so I'm going to draw my little arrows. And this is where the magma is coming up and it's creating the mid-ocean ridge right here. So we've got our ocean water here. So in the middle of the ocean, both of these are oceanic. And then that's where we need to draw our little convection currents that are happening here. And you need to make sure that the red is where it's hot and it's coming up there, and that's what's making this actually spread. So this is the mantle. So the magma is kind of coming up here. And that is extrusive because it's not inside a volcano, it's out. So that's from the lava, and that's basalt. Right, the effects of an oceanic divergent plate boundary, the effect, the thing that is created is the mid-ocean ridge. And an example of an oceanic divergent boundary is the mid-Atlantic ridge. Okay, so look there. It should actually be capitalized. It's the place. All right, so let's move on to the continental. So when both of the plates are continental, they can still diverge. They can still move apart. So here's our two plates. They happen to be continental crust. And as these move away from each other, it's creating this little valley here. And as it moves, it creates this little like step stair on both sides, because it continues to move and it keeps falling down and kind of eroding there. And there's no ocean up on top because I'm on the middle of a continent. So here's my mantle. It again needs to be moving away. So it's pulling, the convection currents are pulling them apart. Here's my mantle. The effects of a continental divergent boundary is called a rift valley. It's literally just a valley that it happens in. And an example of that is in the Iceland Red Sea. So there we go, third of the way done. Right here is the Thingvellir National Park in Iceland. This used to be together, this continent here, and it is slowly and is still moving apart. And it happened a long time ago, and it goes into this whole little valley here on the side. I actually went there last summer when I went with the National Earth Science Teachers Association. It was so rainy and dreary, and I was just not prepared. So I was like borrowing stuff from other people. This was actually used to be together, and like when you Google Rift Valley, a lot of the time this is what you see. So I thought that was super cool, and I really needed to document that. Another divergent boundary, this is the Mid-Atlantic Ridge right here. It's happening this whole way down in this ocean. And they're moving apart. So these continents are still moving away from each other. It's about 2 centimeters a year. So this one is oceanic and oceanic, and the other one is continental crust. All right, moving on to the transform fault boundary. This is when the two plates move next to each other. They slide past in opposite directions. All right, and this can happen between any crust. It doesn't have to be ocean and ocean. It doesn't have to be an ocean and continent. It doesn't have to be a continent and continent. It can be anything. They're just sliding past each other, and this is where you get a whole lot of earthquakes. So since it's no crust, we're not going to draw that. We're just going to draw a little thing, and they're moving and sliding in opposite directions. Effects are earthquakes, because a lot of stress builds up right in between there, and then it all of a sudden just cracks, and that's where you get the earthquake. An example is the San Andreas Fault in California. Here's a picture of the San Andreas Fault in California. It's about 700 miles long, and it's constantly shifting, small amounts, but they have a lot of earthquakes in California, not just because of this one, but because of the subduction that's happening right off of the coast. The last type is the convergent boundary. I'm going to kind of zoom out here. So this is when plates move towards each other. And this can happen between different types of crust, and the different crusts cause different effects on land. So let's just first start out with the different crust types up here. The first one is going to be an oceanic continental. And it's going to be an OC. The next one is going to be just an oceanic, so it can happen in the middle of the ocean between two oceanic plates. And then it can happen in the middle of a continent, the things moving together. Continent. Continental, let's do that. CC. All right, so with the oceanic and continental, let's draw our picture. So grab out your colors again. I kind of already drew this for you, so maybe this will look a little bit familiar. So this is our continental crust, and this is our oceanic crust. And if you realize what's happening here, this is moving together. This thing is called the deep ocean trench. It's going under it because the oceanic one is more dense and it's going to sink underneath that continental crust. Even though it's younger, it's made with a different kind of rock. And this happens in the ocean, probably going to be a little bit over onto the continental plate. The oceanic crust is more dense. And then we gotta draw our mantle. Make sure you're drawing it in the way that it's moving, because it has to pull this down. So they're coming together. So make sure that makes sense in your brain. Our mantle down here. We got our crust. We have two different types of crust. So the effects of this you can already kind of see. We've got a deep ocean trench here. Over here, there always is volcanoes, and that's because this is coming down and it's melting and it's sending that really hot magma up, and it's coming up and it's bubbling through the volcanoes. And the process that happens here at this deep ocean trench is subduction. So let's write all of that out here. Got a deep ocean trench. So we get earthquakes when there have plates that are moving. We get volcanoes on the continental crust. And then subduction is what's happening at that deep ocean trench. And the example is in Chile, in the Andes Mountains. Okay. The next one is the oceanic. So in the middle of the ocean, we have two oceanic plates that are coming together. They're converging. So let's make that a little. One always has to go under the other. So how do I figure out which one goes under? If it's two oceanic crusts, they're both made with the same type of rock, but they're not going to just slam into each other and create what's in the next one, like what you'd see on a continent. It's in the middle of the ocean. It's actually the old one. It's the more dense oceanic plate that actually sinks. So if it's oceanic and continental, the oceanic one will go down. But if it's oceanic and oceanic, it's going to be the older one that has more stuff on it from over time, and that's going to be more dense. And this is in the middle of the ocean, so we're going to draw our little ocean up here. As this is going down, again, it's going to melt, it's going to come up, and we're going to get some volcanoes over here. And we have to draw our mantle again, making sure it's convecting in the right way, so it's pulling it. Here's our mantle. And in the middle of the ocean, we have these earthquakes too, and those can cause tsunamis. We have the deep ocean trench even here. We can get the islands here, and that's how Hawaii was formed. And Indonesia, I'm pretty sure that was the Ark Islands that you guys researched about. So all of the ones that we're going to write here, we've got the deep ocean trench. And that happens because of subduction. It's a process that's happening right at that spot. We have mountains maybe on the top edge of where the plates are hitting, probably pretty small. We have earthquakes, and because of those earthquakes, we probably have some pretty big tsunamis that are happening there. And the mountains are creating island arcs. Let's say mountains and volcanoes are both creating those island arcs. Okay, examples are any arc islands. And actually, I take that back. The Hawaiian Islands, those form from this mantle coming up and creating those islands. So the island arcs here are from this convergent boundary, but Hawaii is a different story. All right, and the last one down here is continental. So in the okay, so if we have two continental plates coming towards each other, what do you think is going to happen? They're moving towards each other. There's nowhere for that stuff to go. We're going to get some mountains here. And make sure that you are showing what the mantle is doing, either underneath or over on the sides. It doesn't necessarily have to be directly beneath it where this is happening. It can happen like over here somewhere, and it's pulling it and pushing it, and it's making this happen. I should write the word mantle here. So we got the mantle and we've got the crust that we're showing. And the examples are earthquakes and mountains. Example, Himalayan mountains. And that's where Mount Everest is. That is the tallest mountain in the world. Here is the Cascade Mountain Range in the northwest in Washington. This happened because the continents and the ocean were coming together. This is Japan. These are the Arc Islands. There's a deep ocean trench because this is moving this way. So we have subduction happening, and that's when this is kind of bubbling up and creating all these little volcanoes here. And here is the Himalayan mountains with continental pushing together, and this is where we have all these huge mountains.